Hey everyone, I've really missed you guys this week. I'm hoping you guys are having a good break. Today I'm just going to show you guys how to subtract fractions, but we're going to start with a little bit of a warm-up. So you can look over here. I have some equivalent fractions on the board. What I would like you to do is to show me how you know they're equivalent. So you can pause this video, do it on your own sheet of paper, and then in a second, I'm going to show you the answer. I'm going to give you a few seconds to pause. All right, I hope you guys are all back, that you have your answers. This first one, we're going to use the equivalent fraction method. We're going to write 1/2. And if we multiply both of these by 4, you'll see that this is, in fact, an equivalent fraction. So I took the top by 4 and the bottom by 4, and we got 4/8. So yes, this is true. Let's try the next one using the same idea. So what you need to think is, what times 3 would equal 9, and what times 4 would equal 12? The answer is 3. So you can see 3 times 3 is 9. 4 times 3 is 12. So this one is also true, that it is an equivalent fraction. Now down here we have to use a little bit of a different method. It's still the equivalent fraction method, but we're not going to be using multiplication. We want to get to 3/5 from 6/10. So we're going to have to use division. And if we divide both of these by 2, 6 divided by 2 is 3. 10 divided by 2 is 5. So that still shows us that this is an equivalent fraction. I like to think of division as backwards multiplication. So if I read it backwards, 3 times 2 does equal 6. So I know I got the right answer. 5 times 2 does equal 10. So that way I know that I got the division right. So I hope that you're able to do that math warm-up. You got similar answers to me. We're going to erase this now. Just give me a second. And today we're going to work on subtracting fractions. Now, to start off, we're going to try to solve, use my red, 7/8 minus 5/8. If we notice on this fraction, both of them have the same denominator, which is the bottom number, so we don't have an issue there. The numerators are different. When you're subtracting, you need the denominators to be the same. So that's good that we have those already the same. I'm going to draw a picture so you can see what I'm doing while I'm subtracting this problem. If I draw one with 8s, it's going to look like that. Now we want to color this in so that we have 7 of them colored in. On this side we want to have 5. So when we're subtracting fractions, we want to take these 5 away from this one. Let me get my glue back. So if I were to take away these 5, I would be left, if I was to take away 5, so we're just going to take those 5 away, I'd be left with two of these left. So if I draw my picture again, over here I'd have 2 left. So my answer would actually be 2/8. A lot of students get confused because they want to subtract the bottom number. But as you can see from the pictures, the number is going to be the same. That denominator, that bottom number, just lets us know how many pieces are in a whole. If we had 8 pieces, we would have 1 whole. So the bottom number, as you can see, stays the same. The top, we had 7 minus 5 equals 2. Let's try one more without the pictures this time. So if we do 8/9 minus 3/9, we know from this picture up here, our bottom number is going to be the same. So I don't really have to solve anything to know that in my answer, the denominator is going to be 9. All I need to do is solve for 8 minus 3. That would be 5. So my answer would be 5/9. On the page, there is an assignment for you to do to practice this. I hope this makes sense, and feel free to rewind the video if you have any questions on this. See you guys.